Okay, so can you hear me?
Of course.
Okay, so good afternoon. My name is Konstantinos Lazaros, but you can call me Kostas. I'm a PhD candidate at the Union University at the Department of Informatics. And we are actually going to delve together through Python programming and data science over the course of the next 5 days or so. I'm seeing something in the chat. Oh, okay, it's about the lecture recording. So, yeah, I don't know where you will be able to get these. We are, I imagine, going to be sending you these through email, through notifications. So, let me start with a presentation of what we are going to be occupying ourselves with. Okay, so you can probably see my screen right now, right? If someone could actually confirm this, that would be great.
Yes, we see it.
Okay, so we are going to be using Python for data science and machine learning. We are going to delve specifically into data preprocessing and visualization over the course of the next days. And we are also going to check out various supervised as well as unsupervised learning algorithms. But before we go on and do all this, oh, what is Python? So I'm guessing that you come from many different backgrounds. So Python is a very well-established programming language. As you can see, it has been named after the Monty Python's Flying Circus, which was a comedy show that Guido van Rossum, the developer of Python, really liked. It's an interpreter-based language, which means that if we do write a Python program, it's going to run line by line, which is something different compared to something like C, where the whole program would have to be converted into machine language before being used by the computer. And of course, it's very popular not only in data science and machine learning applications, but also in other fields of expertise, like web applications, Android applications, and so on and so forth. So the question might be, why are we actually using Python, especially for data science and machine learning? The first reason is because it's a very high level language. So what that means for us is that it's actually very close to the way we would write text in English language. And the reason why this is beneficial for us is because if you actually get a good grasp, a good understanding of the language itself, you will be able to write specific programs that will help you to do certain tasks very fast and very efficiently. Another reason why we really like it is because of its interpreter-based nature. Since it runs line by line, it's actually very easy to debug, which means that if we run into any errors, into any issues with the language itself, we will be able to readily highlight where the issue stems from and basically correct it. The third reason why we like it is because it's what we call in the informatics community as a batteries included language. What that means is that aside from installing the main language itself, we also install with every basic Python installation a series of libraries or packages that actually give additional functionality and utility to the language. Now, what's a library? It's essentially a series of predefined code that has been written by other people, by other teams of people in most cases, that can actually help us run through various different tasks faster and not have to reinvent the wheel every time we want to basically create a very large and complex program for a specific project. So, and the final reason, of course, is that aside from having some native, libraries that are installed along with the language itself, there is also a wide variety of third-party options when it comes to packages that we can use for many different tasks. For example, when it comes to machine learning and data science, there is a very popular package that we are going to see today over the course of the next days, of course, which is called Pandas, which helps us actually arrange our data in a tabular format and process them. So, of course, we've seen what libraries are. We've talked about this a few minutes ago. The problem with libraries is that there are many different versions of its library. For example, I mentioned Pandas, and there is not only a specific version of Pandas. Like many different versions of libraries exist, because libraries are actually being improved upon with extra functionality. Some bugs, some issues that previous iterations might have had are being improved upon. Some code that is redundant is removed, and so on and so forth. Which means that for every different library, there are many, many different versions. Take Pandas, for example. You can see that we have Pandas version 1.2, for instance, and then we also have Pandas version 2.3. So why is that a problem for us, right? So the problem here is that we can't have Pandas 1.2 and Pandas 2.3 simultaneously installed on our computer, whether we're talking about Windows or Linux or what have you. And another issue that stems from this whole thing is that different projects have different requirements. For example, a project that has to do with large language models, for example, might have to make use of Pandas 2.3 for whatever reason, whereas a different project which makes use of more traditional tabular data, clinical data, for instance, might have to make use of Pandas 1.2. So the thing is, how do we actually work around this in order to be able to use both versions of Pandas if we cannot install both of them on our global system, like in our native system? So Python actually has a solution for this, and it's basically the thing that you see here illustrated in the green box. It's called a virtual environment. So what virtual environments in Python actually are is that they are isolated workspaces through which we can actually install many different libraries and specific versions of these libraries. So imagine that essentially a virtual environment is basically like a box, like a toolkit, inside which we actually install specific requirements that are needed for a specific project each and every time that we want to execute code for a specific project. So what that means for us is that we can actually have a virtual environment for project A, which involves, again, clinical data, for example, which requires Pandas 1.2. And then we can have a second virtual environment, which actually has Pandas 2.3 because it's a different requirement for another project that has to do with LLMs or deep neural networks, for instance. So essentially what that gives us is a flexibility to be able to use many different libraries and many different versions or instances of these libraries into our system. But the thing is, okay, I mean, all this is good, but how do we install Python? So before we move further, I got to ask something. Have you got Python installed on your PCs? Could you actually give me a bit of a feedback as to how things are when it comes to Python installations? Do you have it? Do you not have it? Like opening your microphone would work. I mean, I cannot really see the chat, but I could go there. Okay, so to answer your question about VS Code, yes, it is acceptable. You can use whatever code editor you want. And yeah, so okay, Python 3.11 is actually going to work for us potentially. We're going to be installing Python 3.10 as a tutorial for those of you that don't have the language installed on your PCs. Okay, so Anaconda is also going to work. Unfortunately, Python 3.7 or 3.8 is not going to be working for what we want to do, at least for the later parts of this course, because we are going to check out a library which is called PyCarray, and it requires that you have at least Python 3.9 installed. So yeah, Spider or PyCharm is going to work just fine. We're not going to have, just to be clear, you can use any kind of code editor you want. There's no limitation when it comes to that. You just need to make sure that you have at least Python 3.9 installed and below 3.12. So somewhere in the middle between this ballpark is going to be just fine. So having said that, how do we actually go on and install the language? So we're going to see through the series of slides that I have, but you can also check out this video that I sent in the chat. We've created it so that it can actually be a bit of an archive, so to speak, that will help you install the language, even if you want to do it later on after the course is done. So this is pretty much, this course is supposed to be a bit of a hands-on experience. So if you want to, you can, and you don't have Python installed, you can pretty much follow the steps that I'm going to show here in the slides, and I can wait a bit after we're done so that you can have it ready in your system. So the first thing that you need to do, of course, let me go through there. So the main thing that you got to do is join in this website right there. As you can see, python.org. You go through downloads. You check for a specific Python version. For the materials of the course, I've used Python 3.10.11, which makes which basically runs with every single one of the libraries that we are going to check out. So what you need to do is press here and download. And then the next thing that you got to do is basically get the Windows installer for 64 bits if you have, provided, of course, that you have a Windows laptop or a PC. If you have Mac, you can basically go for the universal installer. And if you have Linux, it's pretty much already going to be installed in your system. So after doing this, after actually installing, after getting the installer, downloading it, you will have to open it. This is an older example with 3.8, but 3.11 is going to be pretty much the same thing. So what you will have to do is make sure that you check this option right here, as well as this one right underneath. You got to make sure that this is clicked upon so that you can actually use Python throughout your whole system and be able to create VNVs and whatnot. And this is a fix that we're going to check later on in case we run into issues when it comes to, creating and running VNV, like when creating the virtual environment, that is. So are there any questions so far? Let me check the chat again. Yeah, it is acceptable. So once again, yes, you can use whatever code editor you like, whether it is Visual Studio Code, Spider, PyCharm. Even if you want to use, standard Jupyter notebooks or Google Colab, everything will work just fine. I mean, it's acceptable, totally acceptable. Yeah. So is there anyone that will actually be installing Python right now? You can, of course, check the video, but would you like to wait for? Yes, this would actually be a problem with Python 3.13. It's actually, so here's the thing. Python 3.13, if I recall correctly, is the latest Python version. And the problem with that is that a lot of libraries are not tuned to work with the latest versions of the language. Like in most cases, just to be sure, just to be 100% safe, what is kind of a tradition. Yes, so 3.10.11, this one right there, again. This one. This is the one that I would recommend for this course. I've tested it. It runs with every single library that we're going to be checking out, not today, but in the course of the next day. So today is more like an introductory and procedural course when it comes to setting up a language and, working on with it. Yeah, I mean, if you want to do it with Docker, sure. I mean, we're not really going to show how this is done here in this course, but sure, if you actually are familiar with Docker as a technology, yeah, you can do that as well. So would you like me to give you some time, like 10 or maybe 15 minutes so that you can actually, yeah, of course. I'm also going to write it in the chat so that you can actually have it. This is the version right there. Yes, you do. This is actually an important part. This is actually one of the things that you do have to do. So you have to add it to the path so that you can actually be able to use it later on. Yes. Okay, so I'm going to give you like 10, maybe 15 minutes, and I'm also going to stay in the chat so that I can answer to your questions. And we're going to commence with the main introductory course for Python. So if anyone wants to ask anything, okay, you're welcome. So if anyone wants to ask anything or add a comment, perhaps about your... Yes, we're actually going through a small break, a little break, yes, for those of you that actually want to install the language, 3, 10, 11. So we're going to give a bit of time for that. And we're going to be back with the main introductory, let's say, course for the day, which is going to be... Yeah, exactly. I mean, Vasilis Styrakoglu basically has already the pipeline that we're going to go through. So yeah, we're going to show how we can actually do this. Yeah, but absolutely, this is pretty much what we're going to do. 3, 10, 12, yes. I think this should actually work fine as well. Perhaps. I haven't tried it, so to speak, but yeah. I mean, any version of 3.10 and 3.11 should probably work. Okay. You have the list. Okay. You know which libraries. Oh, so you want to have the list. Okay. Is that what you actually want to say, that you want the list of libraries? Okay, sure. Okay, no problem with that. Okay. Okay, so I'm going to paste the libraries that you will have to install. So there it is. I'm guessing that since you asked about it, you're also familiar with the process of doing it. So I'm sorry if this is actually a bit repetitive. But yeah, what? It should probably work fine. Yeah, George, I'm responding to you for 3.11. So yeah, I mean, you can, of course, check if everything works correctly. We'll give you the materials of the course so that you can actually have a good grasp of whether the specific Python version that you have works or not. And if it doesn't, we can, of course, keep in touch so that we can actually troubleshoot it and, bring in a slightly older version of the language, of course. Okay. So since we're waiting here, would you like to give me a bit of a background? What are you studying? What's your background in terms of informatics, Python programming and whatnot? Would someone want to either write it in the chat or actually, speak to me through the microphone? Okay. Yes, of course. Anastasia.
Okay, greetings. You can hear me, yes?
Yes, of course. We can.
Okay. Yeah, hello. It's my first year on Ionian University in Greece, and I'm very excited to both see and find out what those lectures are about. I have some experience with only Python. Um, I've been working with it since middle school, around second grade of middle school, but only like minor projects, and then moving to more towards Pygame and PyTurtle and stuff like that. It was pretty fun, but yeah, only Python.
Okay. So you are in the Department of Informatics. You're in our school, or
Yep.
okay, that's great. That's great. So we also have some people from the chat. So Stumpf, okay, great. And we also have Dalibor. Okay, great. So glad you guys could be here with us. Okay. So is this your, especially for the guys over in the chat, is this your first, let's say, data science course? Do you have a bit of a background, like sort of an experience with this? Yes, of course. There's also Georgios, right? George. So would you like to speak to
Hi,
us as
yeah,
well?
I don't know if you can hear me.
Yes, of course, we can.
All right, hi, yeah, my name is George, and I am also a student here at Ionian University. This is also my first year, and I'm studying computer science. So as far as my coding experience goes, I basically also started around middle school, and at the start at least, I wanted to learn about web development. I was working towards the full stack web development, a path I found online. But then a few years after, I switched to Python. So I started learning how to code some code. I'm sorry, no, I started with the basics of Python. I worked on some projects of mine. And these past few weeks, I've actually all started to work on a Python project that uses an LLM model to basically create an assistant that can help you work on daily tasks. So that's about my coding experience, and that's also the reason that I was really excited to join these lectures. Hopefully, we'll get to do some practice on that.
Okay, that's actually pretty great, especially the LLM part. I mean, it's actually quite exciting, right? So yeah, we will actually be able to delve into at least the basics of data science, the best practices that is. So yeah, I hope it's gonna be interesting for you. So we also have Evelyn. So would you like to?
Hello to all. I have no idea from computer programming. I've almost been accepted as a PhD student at Ionian University, but my background is on business administration and economics of education and management of education organization. Although I have covered in the past a variety of material related to the management of information systems, software, hardware, social networks, etc., and some implementation of EPR systems. I feel sorry, but I don't have a computer programming background.
Okay, no problem at all. I mean, we are actually going to, make today's lesson is going to be more of an introduction to Python. So you don't really have to worry about that. You will have a textbook with the basics at least. So I think it's going to be quite interesting.
Thank you for your patience.
No, it's fine. So we also have, okay, so we have Matthijs Rans. I'm sorry if I'm butchering your name. I cannot really pronounce it. Okay, so
I have a question regarding the installation of Python. I have Python 11 installed, and
okay.
now should I download Python 10 or 3.10 also and add it to my path?
If you already have 3.11, since you already have it installed in your computer, I'd say that you first check with the course materials. We are going to make them available to you at the end of the lecture. And if you find any issue when it comes to some of the libraries that we're going to be using, like when it comes to importing them, using them, etc., it would be a good practice to uninstall it from your system and go to 3.10.11, the version that I gave you. Yeah. Not because I like the number, but because I've actually checked it multiple times and it actually works with pretty much everything that we're going to see over the course of the next days.
Okay, perfect.
So I think this would be the best course of action for that. So yeah.
And otherwise, I have a bachelor in mechanical engineering. And now I'm from Czech Republic, but I study on Erasmus in Croatia.
Oh, great.
And yeah, that's it.
Okay. That's great. Is this your first data science course? Do you have previous experience?
I had a Python specific course, but data science was only like one part of the whole Python subject.
Okay. So we are actually going to be checking a lot of things over the course of the next days, and we're also going to repeating a lot of things so that we can get a better understanding and remember them. So yeah, you will get a lot of data science through this course that we're going to be having. So yeah.
Nice.
Okay. So I also see George who has raised the hand. So would you like to, introduce yourself and talk to us? We can't hear you. So do you have is your mic open?
Can you hear me now?
Yeah. Now we can hear you.
Okay. All right. So my name is George Handris. I'm also a student in the Ionian University. It's my first year. I haven't had a lot of experience with coding. Everything I've learned up until now is from what we've done with C. And yeah, that's about it. I'm trying to see if I really like the university, and I can safely say up until now it's been quite the experience I've enjoyed, and I want to see where it takes me.
Okay, glad you like it. There is a joke for computer science. So C is basically the language that teaches you pain and patience, and Python as well as R are the programming languages that teach you love. So yeah, I think you're going to like the language and the basics of it if you've already occupied yourself with C. At least I'm hoping you do. So okay, has anybody installed Python through the instruction set that, Yeah, me too. I quite hate C, but yeah, it's a very powerful tool, but yeah, I kind of hate it too. So, okay, so I see that the current version of Python is 3.12. So, Daribor, I think that 3.12 is not going to be compatible with at least PyCarray. So it will be functional for the majority of what we're going to be showing over the course of the next days, but it's not going to be compatible with the PyCarray code that we're going to be running in the end of the course. So if you can, at some other point later on, maybe you could also install 3.11 or 3.10. So yeah. Yes.
Excuse me. You were about to say something. I disconnected. I couldn't hear what you said. If you could repeat it, that would
Oh, yes,
be
of
awesome.
course. Oh, yeah, of course. So what I was actually saying is that Python 3.12 is going to be incompatible with part of the code that we will be running. So we're going to be, and the reason why I say this is because towards the end of our meetings, not today, but in the final days, we're actually going to be seeing a specific library which is called PyCarray, and it's not compatible with Python 3.12, at least from my own experience. So you should definitely go.
Part.
Okay.
I heard the part. I was talking about when I was introducing myself. You were about to say something about C and Python, and that's where I disconnected and I couldn't hear what you were about to say.
It was more of a joke. Like C is
Oh.
basically the language that teaches you a pain and patience, and Python is the language that teaches you love. It was a joke. It was pretty much, yeah, nothing sort of important.
Oh, yeah. Okay. Thank you very much.
Okay, so has anybody actually installed Python. So we are going to, okay, so I see many different comments in the chat about C and C++. Okay, let's not start a language war, please. Okay, so I'm actually going to switch share back on. Wait, what's that? Okay. Okay, so now you can see my screen, right? A confirmation would be wonderful.
Yes.
Okay,
Yes,
so
we can see the screen.
okay, great. So after you've installed Python in your system, this is kind of a spoiler alert. So let me stop running these so that we can actually, go through the whole process together. Okay, so I'm going to stop this as well. Okay, so after you've installed Python, you will have to open a terminal pretty much like this. It can be Windows PowerShell or Shell in general, the CMD. And what you can actually try to do is actually type Python. And if the language has been installed correctly, you should be seeing something like this. Python and then the specific Python version that you've actually installed, right? So how do we get out of this, Python prompt? We actually write this thing right there. So, okay, what we've actually seen so far is how we can actually install the language itself, right? So the second thing that we need to do is basically create our virtual environment, the isolated space in which we are going to install all of our libraries that are required for the project we will be running. So how can we actually do this? We have to go there. Let me zoom in a bit. So this is the command that you should be running. Python /m VNV and then VNV. So what this does is that it says to Python that I want you to create a virtual environment and its name is going to be VNV, like virtual environment. Another way you could actually write this is actually giving this command right there and then putting a dot. And why would you actually want to do this? You would actually want to do this in case you would want to make your VNV compatible with perhaps even Linux. It's more like how we would write in Unix-based systems. So if you have installed Python and it's running correctly through the previous test that we've run, I'd also like you to type in this command as well. I'm going to zoom in a bit further so that you can actually check it out. You can see my screen, right? I mean, it's visible, correct?
Yes,
that's
it's
fine.
visible.
Yes.
Okay, great. So did you copy the command? I'm also going to actually type it into the chat so that you can actually have it. Just in case we move on and someone kind of loses track of what we're doing. So after you've done this, after you've actually run your command, what will happen is that you are going to have a folder which is going to be named VNV, right? So the first thing that we got to do is actually turn it on. Or in other words, we will have to find a way to get inside the VNV so that everything that we install is going to be directly in there and not into the entirety of our own system. So how can we actually do this in Windows? Through this command right there. This is the command that we will have to use. If I press enter, you're actually going to see that in PowerShell, I now have this parentheses over there with the name of the VNV that I've created, which is a dead indication that right now, whatever type of code I'm going to type is actually going to be within this isolated environment that I created for my project. Okay, so the command, once again, I'm going to write it in chat so that you can actually have it. Oh, so in Python, there are two basic file formats. You have .py, like this one, as you can see, and then there is this one, which is for Jupyter Notebooks. And you're going to see what a Jupyter Notebook is, a bit later on today, that is. Okay, so the other command that you're going to have, at least on Windows, is going to be so that you can actually activate it. If you are on a Linux-based system, what you will actually have to give is this. If you're using Linux for whatever reason. Okay. So now we are inside our VNV, and what we really got to do is actually start installing our libraries, the packages that are required for our project, right? So how do we actually go on to do this? We can do this, by actually using or choosing one of two approaches. So the first thing that we can actually do is type pip install. This is the basic installer that comes with Python. This is the tool that we're going to always be using when it comes to downloading and installing our libraries. And what you can actually do is actually type this same command multiple times, each time using it for a different library or for all libraries together. For example, if I wanted to install pandas, for example, and something else like matplotlib, which is for visualization with Python, I could do it like this. However, a different, more streamlined way of doing this would be to create a requirements.txt file, which is pretty much what you see right there. You get inside this requirements file and you type these three package names. These are basically the same ones that we saw before in chat. Oh, so yeah, this is where the workaround actually comes into play. So there is a solution for this. Let me stop my sharing for a moment and go back to the PowerPoint presentation. So what you actually got to do for this is that you have to actually have to give the correct command to the PowerShell so that you actually have the ability to run scripts. So I'm also sending you a source for this on how to work around this. So basically, let's go through it together. Let me share my screen once again. So you can see my screen, right?
Yep.
Okay, so what you will actually have to do to work around this is that you will have to go to PowerShell, like this. You run it as an administrator. I'm not going to do this right now because I've already done it. And after you do this, you get this command, you copy it, and then you paste it, and then you press enter. And through that way, you will be able to enable, script execution. So this is the course of action that is recommended by, Python users all over the world, essentially. So if that doesn't work and it's a more intricate, more complex type of issue, we can actually check it after today's lecture. You can always send me a message. I'm also going to provide you with my email in case you want to come in contact with me for whatever question you might have. So yeah, if this doesn't work for you, we will find a way to make it work. So again, these are the libraries that you will have to install. So let me, oh, you're welcome. So let me just, copy and paste them again in the chat. Oh, I see Anastasia actually, yeah, is there a question?
Yeah, I wanted to ask, in case we have Visual Studio Code, is the tutorial the same, or do we have to follow something else?
No, it's the same thing. I mean, essentially the tutorial is based on Jupyter Notebooks, which are also compatible like 100% with Visual Studio Code. So there's no real issue. I mean, if this is the code editor that you prefer, then yeah, fine. There's no problem.
Okay, thank you.
You will be able to run the course materials through any, kind of, oh yeah, let me show you once again. It's this one right there. So you basically go to this page, you follow this, so you open PowerShell and you run it as an administrator, and then you basically copy this part right there. And then what happens is that it will actually show you a bunch of text. What you will have to do is actually type Y, which stands for yes. It's a shortcut for yes, and then press enter. And that way you will actually change your system's policy so that you can actually run scripts. So yeah, this is, again, this is it right there. I'm going to copy it and give it to you in the chat. Okay, so did anyone actually get these? Have you created the requirements.txt file? So I'm guessing you have. So the very next step into when it comes to installing these libraries is actually doing this thing right here. So what happens is that instead of actually specifying the names by myself, the names of the libraries that I want to install, what I'm doing is that I'm telling Python and pip, the installer that I'm using, that I want you to read what's within this specific txt file right there, and I want you to install everything that exists within this. Now, if you actually try to run this code, and I'm going to also copy this command and send it into the chat so that you can actually have it. So wait just a bit. Okay, so this is the command that you will have to run. So this will actually take quite a bit of time because the libraries that are located within our txt file will also install additional libraries that are required. So it might take somewhere between like 30, maybe even 40 minutes. So in order not to, tire you up, because I understand that you also had a lesson, before what we're actually doing now, I'm going to move on to some of the basics of Python. And if you run into any sort of issue when it comes to installing and having issues with the libraries and their versions and whatnot, we can, solve it and sort it out either after the lecture or at some other point later on in the day or in the days that will actually follow. So, okay, so what we actually have is that we've installed Python. We created a virtual environment for it. We activated it. And we also installed all the necessary libraries that are needed for the project that we will be running. So how can we actually check whether our libraries have been installed or not? We can use this command right there, which is called pip list. As you can see, it's running a bit late because I actually have a lot of libraries, as I said. So there we go. So what goes on with this command is that I can actually check out every single library that I've actually installed through the previous command that we saw. And I can also check the different versions of the libraries. So is there someone opened the microphone, I think? Did someone want to ask something? Okay, I must be hearing things. Okay, so how can we actually go on and use this? Why is this useful for us? Because if we actually do a certain command, which is called pip freeze, we can also get not only the libraries, but the specific version of each library that is required for my project. And this is something, and we can, of course, save all of this into a txt file and, give it out to a colleague of ours or the client to which we will be giving our algorithm to so that they can actually set up the exact same environment that we've actually, used as well. I'm sensing that someone wants to say something. So did someone open the microphone? Is there a question? Let me check in the chat as well. Okay, so is everything, understandable up to this point? Are there any questions whatsoever? Okay. So the next thing that we have to do, since we're into our VNV and we've installed everything that is needed to work with said VNV, is that we need to open a code editor so that we can actually start writing code. So if you wanted to use Visual Studio Code, I don't have that installed in this specific virtual machine that I'm using, but the command that you would be using would be this thing right there. So if you have Visual Studio Code, you can actually try it out. It's pretty neat. You can go through PowerShell, and if you type this command right there, it's code, then backspace, and then a dot, it will open Visual Studio Code. And you will be within your project, and you will use the Python kernel that has been created with the virtual environment. So this is one way of running things. The other thing, the other approach that we will be using is writing this command right there. Jupyter Notebook. Because we are going to be using notebooks for these series of lectures. So I will be giving you these, the first one and the second one. The second one we will be doing tomorrow, but you will have it from today. It's going to be sort of a spoiler thing, but okay. So what is a Jupyter Notebook, right? So I've written before in the chat that there are basically two different Python file formats that we can use. So you can have standard Python scripts, which would have .py at the end right there, or you could have this kind of file. This is the IPYNB, which is a notebook. So what is a notebook? It's basically what you're seeing right here. Why do we like notebooks? Because it's a very, let's say, beautiful interface that we can be using in order to actually write code and also add comments, which are in the form of Markdown. Right there, you can see that I can execute this cell and I basically get a title and I get comments for what is Python and whatnot. I can add photos to it. Pretty much the whole installation procedure that we've run in before. And right underneath, aside from the photos and the comments, I can also add code cells to it. Code cells that I can also run. Like this one, for example. And the reason why we like this so much, especially when it comes to data science and machine learning, is because we can create very intricate, very beautiful reports that we will be giving to our colleagues, whether they are data scientists and computer scientists, or whether they are coming from a different field of expertise, whether it is doctors, biologists, people that are experts in economics, etc. So how can we do this after we created this notebook with everything that is there to see? One of the things that we could do is actually export it as an HTML file, which would open through your browser, something like Microsoft Edge, for example, or Firefox. And the result of this would be the exact same thing that you see right here, along with the photos and the comments, as well as with the executed code cells that we're going to, be running like right now. Okay, so does anyone actually have access? I mean, have you opened something similar to that? Have you had any issues so far? Let me also check the chat. Yes, of course. If you actually have it with Anaconda, yes, you can use that if you want to. Yeah, no problem. So to make things 100% crystal clear, if you already have Visual Studio Code or whatever other code editor you prefer, you can totally use this. There is no problem. Feel free to do it. If you have Anaconda, you can use this as well, of course. What we're going to be seeing here together is a specific, pipeline, some specific practices like Jupyter Notebooks, how to create VNVs and whatnot. But that doesn't mean that it's the only way to do things. Like, it's one of the standard ways to do this, of course, but there are many different other approaches that you can use, not only to install libraries, but also to, write and edit your code. So if you're more familiar with one of these other approaches, like Anaconda, for example, or Visual Studio Code, then by all means, feel free to use them. Okay, so right now we are going to delve into a bit of Python. So we're going to check out the basics for today. This is, again, the first meeting is a bit more procedural. It's a bit more introductory so that we can all be in the same page when it comes to coding. And from tomorrow, we're actually going to delve more into data science, like pre-processing, visualization techniques, etc. So so the first thing is to basically assign values to specific variables in Python. So how do we do that? We use this equal sign right there. So if I go to this code cell, which I've already run, as you can see, how do I run this code cell when I'm in a Jupyter Notebook? I can either press this button right there and it will run, as you can see, or I can click into the cell and then press Shift Enter. It's going to have the exact same effect. And you can see here that this is the number that showcases the hierarchy of executed cells, which means that this is the third cell that I've executed when it comes to code, because I've actually run this cell like 3 times in a row right now. Okay, so how do I actually print the contents of this variable, right? There is a built-in function. Oh, let me zoom in a bit, which is called print. So print number will actually print the number that I had right there. Pretty much as this, like what I had right there. I can also add, other elements. For example, if I want to add my variable's value, I can also add a bit of a text. So I can have a lot of flexibility in terms of what I'm going to print as an end final result. Aside from this, what if I actually wanted to check out what a specific function actually does? For example, I know that there is a function called round in Python, but I don't really understand what it does. I don't really know how it works. So if I press help round right there, I can actually have a bit of a description as to how it actually works. What if I do this, however? What if I actually have round and then I have a specific value within it? Then help is not going to be giving me the final result when it comes to round. It's actually going to give me a result in relation to the value that I given to round itself. So if I actually execute this code right there, the final result will be a description for minus 2.01, the value that I have in here. So be very careful when you're actually using a specific function along with values, because if you're using help, you will be seeing the end result for the value that you have and not for the function. And you can see, of course, that they have extensive documentation for what this function does, the types of variables that it gets, the output, how you should be using it, etc. And there is also a function called type in Python. These are very basic things right now, but yeah, which actually helps us understand of what type the variable actually is. And what that means for us is whether number is an integer, whether it is a floating point number, like with a comma, whether it's a complex number, etc. So in Python, these are your main data types right there. It's in the form of matrix, as you can see, and this is actually a markdown matrix. So again, this is to basically showcase the flexibility that is provided through the language as well as through Jupyter Notebooks. Okay, so if you want to write a piece of code, pretty much like this one right there, and you also want to remember what it's actually doing. Of course, this is a simple example, but you could have written something, far more complex than this. You can also add comments. So you actually add comments for the hashtag. So if I come here and actually press hashtag, this is a test, I'm actually writing a comment. So this is a single line comment, and there are also multiple line comments, and you can basically create a multiple line comment by using these, squiggly brackets. So if I do this, I've created a multi-line comment. And this is actually very important because if we create our own function, like if we create something like our own version of round, and we want to actually help people understand what it actually does, what we would do is actually also add a multi-line comment such as this within our function so that people can actually see this as sort of a user's manual to what the functionality of our program actually is. Okay, and we can of course print what goes on there in multiple lines. As you can see, we basically get a multi-line text. So the basic arithmetics in Python are pretty much these. You have some standard operators for specific mathematical notation, and you can see some examples of that right there. I'm going to run these a bit fast. A thing that is very important right here is to always keep track of your parentheses because there is a specific priority as to how operations are done. So parentheses take place first, then come powers, and then multiplications and divisions, and then you have additions and subtractions. So if you're actually trying to create a but a complex mathematical operation that involves many different sub-operations within it, pretty much like what you see here, you should always keep track of what's within parentheses. And the reason why I say this is because, as you can see here, through this example, this is, a bit of a ridiculous example, but okay. We get this final metric right there, the height in meters. But if I actually do this, if I remove the parentheses, I get this number right there, 26.8. So after, given everything I've said so far, would someone like to interpret the result that we're seeing? Like which operation came first and why I got this kind of result? Would you like to, so that we can actually give more of an interpretation for the people that do not have a background in informatics and computer science, that is, so that we can all be in the same page. Would someone like to help me here, to interpret this result so that we can all be in the same page, have a very good understanding of this concept?
Since you are adding centimeters to meters, the results doesn't really work because in the first part head height centimeters, it's actually in centimeters, but the other one is in meters. So you cannot add two values that are in different units.
Okay.
Because the meters are because you are dividing by 100.
Okay, so yes, aside from this, I would add that this is more of the kind of thing that I'm trying to say here with the priorities of the operations that we have. So the main reason why we're getting this result is not because of meters and centimeters. I mean, they're both in centimeters, as you can see. The problem is that we have this division right there. Is that what you wanted to say? So,
yeah, I think I didn't explain it correctly, but yeah.
Okay. So I'm kind of reiterating. So yeah, exactly. So the problem here is that because of the way we've written this expression right there, what happens is that the division is going to take place first. And then we're basically going to have my height in meters, and we're going to add it to the hat's height in centimeters. So yeah, basically the interpretation that you gave is correct, but what I actually wanted to focus on was pretty much the priority of the operations that we have. So you should always be careful to actually put parentheses where necessary. Of course, that is. So is that, totally understandable by everyone? Are there Any questions for the non-informatics crowd? Okay. So another thing that we can actually do is, is actually execute typecasting. So what that means for us is that we can take something like an integer or a floating point number and actually convert it into a different type of variable. For example, we can actually convert something like an integer into a float, which is going to have a comma and whatnot. We can also do the exact opposite thing, basically get a float and transform it into an integer. And we can also get numbers in the form of text, as you can see right there, transform it into a real number, into an integer, and also make operations with it, like add 1. And as you can see, this is the result right there of this final line of code. And then there are also some operators in Python that are known for overloading, which means that specifically these two operators, like the one that we would use for addition and multiplication, or actually, then these can actually be used for other things aside from their, main, basic attributes. So, for example, if I have this number right there, and I actually have, this text, which is spam, okay, and I multiply this by 8, which is the spam amount, what I'm actually going to be getting is like spam written like 8 times. Okay, and the same thing pretty much happens in this case right there. So if I actually have a recipe like, with specific ingredients, let's say this is another kind of funny example, but okay, what I can do is get the recipe, or rather the elements within this string right there. I can add this part, and then I can add a comma and actually get the spam amount in the string format. Like I basically transform this number into a string, and I get this text right there. So this is actually another example to showcase the flexibility of the language itself. I can actually work through many different data types. It doesn't matter what it is. And it might seem a bit funny to actually check out results such as these, which are pretty simple, but this is actually very important, especially when it comes to working with very large data sets, as we will be seeing over the course of the next days. So we also have if statements. So what that means for us is that we check whether a specific condition is true. If a condition is true, a block of code is executed. If it's not, then we can add an elif, like if there is a second condition, or we can basically terminate this and go to a final, default course of action when it comes to code execution. There are also comparison operators, which are a way to basically compare between element values, as you can see here in the example, but I'm going to, move on a bit so that we can actually see something which is a bit more important. So, and the more important thing that I want to check out right now is different types of lists. So why that is actually important is because in most cases, data in Python, when it comes to data science, come in the form of some list, whether it is a dictionary, a tuple, a set, a list, or a pandas data frame, which is the last thing we will be checking after all these. So a list is essentially, I would say, a fancy way in Python to describe vectors and, by extension, arrays. So a list can contain any kind of element. So you can have strings, you can have integers, you can have floats, what have you. You can also have a list within a list, which is sort of a listception, so to speak. But yeah. And this is the reason why we actually like them so much. They are very flexible and they are a very powerful tool to be able to store many different types of data that we would potentially be using in a large project. And then, of course, you can actually check here that we have, different ways to tap into the elements of that list. So one of the things that you should keep in mind is that Python is a zero-based language, which means that counting starts from 0. So the first element right there, which is spam, this text right there, would be element number 0. The second one right there would be element number 1. The third one would be element number 2. And element number 2 in our case is, as you can basically see, a list within our larger list right there. Another thing that we could also do is actually start counting backwards. What that means is actually start from the end and move up to the front. So if we actually wanted to do this, we would actually start counting by -1. So if I want to get this final element right there, I would actually type not kitchen 0, but kitchen -1, for instance. And let's check this out right now. Of course, as you can see, we can get many different types of elements within our list as well. So having said that, can someone actually tell me what this piece of code actually gives me? I mean, why did I get an 8 right there? Let me zoom in a bit further. So would anyone like to actually try to interpret this final result that I got from this list? Any volunteers?
Since you have the 2s 2 times, so it looks, firstly, it looks at the kitchen and it gives you the second list, the second part of the list, and then it gives you the 8, which is like inside the list called kitchen.
Exactly.
Which is 8.
Exactly. That's totally correct. So essentially what happens for everyone, again, I'm reiterating, is that you get the third element of this list right there, which is, as you've correctly said, this list right there. And then it basically taps into this list as well and gets the third element within that list, which is spam amount, which is, of course, 8, as we've declared before. So, yeah. So, okay, what else can we do? Of course, we can actually create an empty list. Why would we actually want to create an empty list? This can actually serve as the basis for, filling data up. For example, we might have a specific table with data and actually, run a process like get the mean value or the standard deviation and whatnot, and then have these values stored within a new list. So the way we would start through this process would be by creating a new list right there, which would be empty, of course. And if you actually go on and check the contents of the empty list, of course, you would be getting this thing right there. Another command that you can actually run for lists is len, which actually provides us with the length of the list, or rather the size. How many elements does this list actually have? And you have 4 elements because you have this string right there. You have an integer, you have another list, and then you also have a floating point number. And of course, you can basically do the same thing for the second list right there, as you can see from this piece of code, which is why we get 3, because we have 3 elements within this, smaller list, which is part of this larger one, of course. Okay, so another thing that we can actually do is add more elements to our list. How we can actually do this? Through append. So if I actually run this command right there, what happens is that a new element is actually added at the end of my list. So I already have this right there. So at the end, so this would be element -1 if I start counting backwards, which once again, and you can basically see the same thing right there. So if I add new elements within my list, the index will also change. So always be aware of that. If you are using a list and you're filling it up with new elements, you will have to check your indexing. Okay, so another command that we can use, of course, would be, these are now some commands that are used for basic operations. It's basically the same thing as before. So let's run them just for a good measure. Okay. And then, of course, we can also use insert, aside from append, that is, which actually helps us add new elements within a specific part of the list. Like this is going to add a new element, which is called eggs, at the second, part of the list, at the second position over list, which is index number 1, since the first one is index 0. Okay. And the same thing can be pretty much done with, other lists. This is another example that actually showcases how append works, just to get a good understanding behind it. So if we wanted to remove elements within a list, we would use either the remove command. So as you can basically see, what I'm doing is that I tap into my object, my variable, the one that I created, and I use specific functions that are, built into Python. These are also called methods because they are a method of basically tapping into a specific variable or object within Python. And if I don't want to use remove, I can also use pop, which does not take specific values, but actually takes specific indices of positions within the list. And if I do this, of course, you can see that more spam has now been removed. And the second element that I had in this position right there, which was eggs, of course, has now been removed. Okay. So by using lists, I can also create matrices. So again, in Python as well as in other languages, matrices are nothing more than essentially lists of lists. And the way you can actually operate through them is pretty much the same as you would with your standard vectors, your standard lists. So as you can see right there, I've defined a matrix which consists of 2 lists, and I can tap into its elements in the exact same way that I did before. However, there is actually an issue regarding matrices and lists and the way we actually operate with them. And the same rule, the same thing pretty much applies with Pandas data frames, which are the gold standard when it comes to data science and machine learning. And that has to do with pass by reference errors. So what happens here is that I have this matrix, right? So I actually want to create a copy of this matrix. I'm going to call it matrix 2. Okay. And what I'm doing here is that I'm actually tapping through this command. What am I doing here is that I'm going to the second list of the matrix. So this is list 0 and this is list 1. Okay. And I'm actually getting the second element if I go in reverse. So this is -1 and this is -2. So what I'm basically doing here is that I'm saying that, you know what, you should get this copied list. You should gain access to 5 right there, and you should change it. You should make it into a 10, right? And then I want, since you've actually done this operation in matrix 2, I want to check what's going on in matrix 1. And the problem that you can see here is that even though I didn't really operate on matrix 1, I've only changed matrix 2. What happens is that I actually accidentally changed the value of matrix 1 as well. So why is this happening, right? So now it's time for a bit of drawing. So let me actually open Microsoft Paint for a bit. And also to answer to your questions, yes, you can create games with Python. Yeah, you can certainly do this. There is by game. Oh, you want me to repeat before? Okay, so do you have a question? Yeah, of course, please. And just to answer to Christos, yes, I'm actually going to be sending you this file by the end of today's course so that you can actually have it and pretty much run everything we are seeing together, right now. Yeah, it was actually part of the Monty Python thing. Yeah, so it was sort of an Easter egg for the language itself. Yeah. Okay, so did Dalibor actually have a question for us? If you want, you can also open your microphone. I mean, so while you do this, let me also open. Oh, okay. So let me reiterate what I was actually saying. Let me share once again. Okay. So, oh, wait. The problem that I have, and be careful for what you're actually going to witness right now, because I'm a left-handed user and I'm actually using the mouse with my right hand. So this is going to be very fun. It's basically going to be like an art course or something, like an art attack. So, or a heart attack, whatever you might prefer. So yeah. So what actually happens is that I have this matrix right there. This is called, let's say, matrix 1. And what I actually do is that I create a copy of this, right? Which is going to be called M2. How did I do this? I actually said that M2 is equal to M right there, right? However, when I actually tapped into the second element in the middle of M2, I also changed accidentally the second element in the middle of matrix M, the initial matrix that I started out with. So why is that? The reason behind this has to do with the way computer memory actually works. When I create a matrix M right there, imagine that this is the computer memory right there. What happens is that I have a specific cell within the computer memory where this matrix is actually stored. In computer terms, this matrix points to this particular address in our computer's memory. When I'm actually creating a copy of matrix 1, when I create M2 through this process by basically saying that M2 is equal to M1, what I'm actually doing is that I'm not creating a new memory cell, which is going to point for this matrix. I'm not doing this. What I'm doing, which is wrong, by the way, is that I'm actually creating a second route that points in the exact same memory cell that this matrix also points to. So essentially what I end up with is two, let's say, arrows, so to speak, two pointers that actually give me or send me back to the same exact position in the memory where these elements right there, these numbers, are actually stored. And thus, if I make a change in M2, I'm also making a change in M1, or M in this case. And this is actually a very important, a very serious issue, because the same rule applies when whether we're using matrices like the one that you saw before and you're going to see again in a while now. And the same pretty much applies when we're using pandas data frames, which again is the main data structure that we're using when it comes to working with, Python data science projects. So what we actually want to do out of all of this procedure is be able to copy the contents of M to M2 and also create a new part, a new cell in memory, which will be different than the one that I start out with. So how do we actually do this? There is a specific command that helps us. Oh, yeah, exactly. So Arian is actually a bit of a spoiler alert. Did a spoiler alert for us? Yeah, so this is exactly what we do. We're actually going to make a deep copy for our matrix. Yes, exactly. So let me share my screen again so that we can go back to the notebook. So exactly as you said, we are actually coming down here. We can basically run this part. And what happens is that we create, as you've said, a deep copy of matrix by basically importing this library and using this command. So that way we've actually created two different versions of our matrix, which point to different addresses in our memory. And thus, if I now change, as you can see here, matrix 2, matrix 1 is left intact. So I know that this can be a bit of a handful, especially for the people that do not have a background in computer science. So are there any questions when it comes to this particular topic? Anything you would like to share with us? Let me also check the chat once again. Okay. Okay, so let's move on. Again, we can actually tap into the elements of our matrix in the same exact way that we've done so with our other lists. So again, it's essentially a list of lists. So the same rules that applied for our list also apply here. Be careful when you're using list with a string like this, because it's going to basically break it down to the individual letters of the string itself. So a string is basically a sequence of words in Python, or text. And then of course you see the fact that we can actually perform any sort of numerical operation on our matrices. So we can not only run with multiplication and addition and whatnot, but we can also perform logical assumptions, whether a specific number is located within our matrix or list or whether it's not. So sets are essentially another array structure that we use in Python. You can see that we can use it with curly brackets and separate elements with commas, which is pretty much what we've done before, but with squared brackets in the case of lists. And the difference here is that elements are actually kind of frozen, in the sense that if you actually plant specific elements within a set, you cannot really change them out. And the other thing that you should also remember is that there is no specific particular indexing, like there is no specific order as to how the elements are arranged within the set itself. Aside from this, however, you can also create sets by using this command right there. This is an alternative way of how you can actually create one, and then of course, print it right there. Okay, and of course you can use a for loop in order to be able to tap into the set and basically print its elements. So right there. I used this print part right there, print blank, in order to be able to also leave this blank space right there so that elements are not clouded, on top of each other. So if you want to create a similar thing, like you can either do it like this, or you can actually do it like that. How do we add elements into a set? You can use the add command, which is a bit different compared to what we had before with append. Okay, or you can actually add multiple values within your set that can actually exist within a list. So if I actually wanted to add all of these elements within my set, I would actually use update. And once again, what you can actually see is that there is no particular order as to how elements are stored within my set, right? So another structure that we use when it comes to arrays, and again, these might be a bit tiring right now, but these are, again, the basics. It's more of a procedural thing that we have to run through. And a lot of the things that we're going to be checking next days are going to be based off of these, basic data structures. So the more we see them, the more we'll get a better understanding of what's going on later down the line. So I think there's someone. Yes, George. So in which part are you actually referring to? Which one would you like me to repeat? Can you hear me first of all? I mean, Oh, yeah. Yeah, sure. Would you like to move on a bit so that we can actually see a bit further on the rest of the data structures that we haven't come back to it a bit later? We will come back, however. I promise that. Is that okay with you? Okay, thanks. Okay, so another data structure when it comes to arrays are tuples. So tuples, again, are an array structure, as you can see right there. They are sorted in specific orders, and we cannot really change their elements. And an element can be represented multiple times. So it's basically what you see right there. So essentially, you can either initialize elements like this, and you can also rename them. So what you're doing right there is that you're tapping into the values that exist within this tuple. And what you're doing is that you're actually renaming them. You're giving them a new naming convention. So red is going to become spam, or rather the value of spam is going to be part of red, green is going to be part of beans and whatnot, and white is going to be part of milk. So if I go ahead and print these, as you can see, I get the initial values of my tuple. And this can actually be quite beneficial in real problems, in real data science applications, especially when I want to annotate specific samples with specific features or specific attributes, whether that is in biomedical problems, for example, which is my field of research, for example, the state of a specific patient, or whether we're talking about the state of a specific stock, if we're talking about, uh, stock exchanges and whatnot, or what other areas might be of interest in terms of the project that we're working on. So just like with tuples and lists, we can also perform different types of operations. And then we move on to dictionaries. This is actually one of the most important. This is actually the most important of the classical, I'd say, array-like structures that are basically side by side along with lists. So essentially what a dictionary is, so first of all, we actually initialize it with these curly brackets. And what they are is lists that include pairs of keys and values. So the keys have to be unique and the values can occur multiple times within our dictionary. And again, this is another, simple, silly example. But to put it all into a bit of context, we would actually be using dictionaries in order to rename specific value names within, a real data set. For example, if we wanted to use a specific algorithm like for classification, we would not be able to use values like red or spam or green, like, string-like values. We would have to transform these values into specific numerical ones, categorical values, of course, but numerical nonetheless. And the way we would actually do this is through the use of something like this, through the use of a dictionary, which would actually helps us map this kind of difference between strings and numbers. And of course, we can gain access to the keys that are available within the dictionary itself. We can gain access to the values, like what we have after these dots right there, or we can actually get access to the entire pairs of keys and values, which are in the form of tuples, as you can see. And then, of course, we can perform operations, which is pretty much the same classical thing that happens with every other array data structure that we have in Python. And one of the things that you can see here, again, just as a reminder, even if you have a dictionary and you want to copy it, you should, use copy once again. This is basically an alternative to deep copy. So it basically has the same kind of effect, which is something that we're also going to describe after we're done with the rest of our data structures. Of course, we have while loops, which again take into account a specific condition. and you can run specific parts of codes. This is basically a way of automating specific procedures. You can do this with for loops as well. Okay. And you can also create your own functions. So pretty much like what we saw earlier with help and round and all of these things that are built into Python, we can also create our own functionality, our own chunks of code that are packaged together in order to, execute specific tasks in an easier and more efficient manner. So for example, if I wanted to create a simple function that just prints hello world, as an example, I would do it like this. So the way you actually start functions in Python is through the def keyword. Def stands for define. Then you write a name, for example, tst, and in the parentheses, you actually have to specify the arguments that the function actually takes, or rather the inputs that the function receives in order to perform a certain task. Then you basically use semicolons, and if you want to print a specific value, you would actually use the print function as we've seen earlier, or if you wanted to return a specific value to the user, to the end user, you would use the return keyword. So if I actually had A and B as values and I wanted to return the final addition that happens between these two numbers, let's say, I would actually return this. And I would also put it into a parentheses in case I wanted to add another operation. For example, I might wanted to add something like this and come back here and add this element as well. If I'm writing a function and I'm not sure about the functionality that it's going to have, I can write the name. I can even create a comment for it, or a docstring, which is pretty much a multi-line comment that describes what it does. And before moving on with the final, commands that I'm going to write within it, I can actually use pass, which is an argument that states that, this is a function that is in the works. Ignore it for now. This is pretty much what it does for our Python interpreter. And as you can see, we get multiple examples of functions, which is pretty much the argument that you receive here. And if I actually run this, you're going to see that this is the name of the argument that I have, and this is the variable that I have. So in this case right there, this particular part of the code is equal. It's basically the same thing as writing this. So even though, and this is actually to make things clear for anyone that is confused, this is the name of the variable, of the argument of our function, and this is an outside variable that basically takes on the role of this internal argument. And then of course I can actually get specific elements. So if I have something like a list or a tuple with specific values within it, I can use this asterisk in order to be able to gain access to all of them. This is basically done so that I can gain access to their positions in the working memory of the computer and basically be able to print them or use them for whatever else I might want to use for. So after having said all these, the final data structure and basic part of Python that we're going to check out today is data frames, pandas data frames to be exact. So we've already seen things like arrays and matrices and how we can actually work with them. So what is a pandas data frame and how does it differ, right? This is a toy example, of course, but a data frame is this thing right there. It's basically a matrix or a table, if you prefer, that is very tidy and intuitive in the sense that it actually helps us have a framework through which we will be able to get a better understanding of our data. And by extension, a better understanding of how to work with our data, how to process them, how to visualize them, and how we can actually use them in order to make predictions that matter, accurate predictions for a specific problem that we have. So you basically have columns, which are also named as features or measurements. And you also have lines or rows, which are also known as samples. So each row represents a specific individual, whether that is a person, whether we're talking about a cell, if we're talking about transcriptomic data sets, whether we're talking about, for example, like a house that has specific attributes like a specific address, a price, or whatever, and so on and so forth. And just like with regular arrays and matrices, we can perform certain operations with them, but these operations are going to be much faster compared to using a standard array. And the reason behind this is because the people that created Pandas data frames actually use libraries that are based in C and C++ programming. So they actually got their hands dirty for us so that we can actually have a very good, very precise framework through which matrix operations happen lightning fast. There are other frameworks like Polars, which are slightly different to Pandas, which is what we are using. But Pandas is pretty much the gold standard when it comes to data science, hence the reason why we stick to this and we don't really move to anything newer, at least for now. So how do we actually, perform operations when using data frames? The way of thinking, the strategy, so to speak, is very similar to what we would have with other types of lists. So for example, I have this data frame right there. And what I'm doing, I'm tapping into the name, this particular column right there. And I want to check out all the unique names that exist within this column. So I can see that I have like Alice 2 times. Okay. So if I actually do this right there, if I execute this code, I'm getting the unique names that I have within this column. There are other things that I could do, of course. I could actually use value counts. What that does is that I actually get the values from this particular column. It could be from any column, but we're using this as an example. And I want to see for each of these unique values, the number of their occurrences. So what I can actually see is that HR can be found like in 2 rows, or in other words, in a data science problem, we would say that 2 of our samples, 2 people are actually working in the HR departments, 2 actually work in IT, and 2 work in finance, so that we can actually get a more concrete interpretation of such a result in, a toy example kind of condition. And then, of course, we can make more complex style of operations. So we can actually get all the elements that actually have an age which is larger than 30, of course. And by doing this, we tap into the entire data frame and we get the 2 rows, the 2 samples, the 2 people, whatever you want to call it, for which this condition is actually met, for which is actually true. And we can also group by specific elements, like we can group by the department, which means that we will actually get for each department right there the values that are represented, like we are going to get all the values that are represented for HR, and then we can find the mean for that. This is another, type of complex operation that we can run. Okay, so tends to stick sometimes. So as you can see, and this is actually very powerful. This is, again, a very simple example, but the reason why this is powerful is because if I have a very large and complex data set that includes thousands of lines or rows and thousands of columns, through such operations, I can actually get very easily and efficiently some of the descriptive statistics that would actually help me understand what is going on within my data set in terms of distribution, in terms of missing values, and so on and so forth. But I'm getting ahead of myself. We're actually going to check these tomorrow and in the following days, of course. We can, of course, sort values, again, by an ascending order. or a descending one in this case. And again, we can also create a new column by basically adding it right there and creating a new condition based on what already exists within our data. And as you can see, I basically added as adult and the value of true because all of them are, above 18 years of age. So this was the first presentation that we had for today. I'm going to stop sharing for a bit. So are there any questions in regards to what we've seen so far? Okay, great. So just for the sake of a bit of feedback, how did you find today's? Yes, of course you will. I'm actually going to be sending this file. Yes, of course. You're actually going to get every single resource that we saw today and everything that we're going to see in the next days of our course. When it comes to recorded videos, I don't particularly record them. I'm told that it's being recorded right now. So I'm guessing that the people that are doing so will upload it and they're actually going to send it to you over the course of the next days. So you will have the videos and you will certainly have all of the materials that we're going to be seeing, today and the rest of our days together. So, yeah, perhaps I'm answering to Petar. So we haven't decided on it yet, but the word on the street is that yes, you might probably have, yeah, a bit of a sort of a project. I think it's going to be optional, but don't quote me on that. We're not concrete about that yet, but the project will actually concern everything that we I'm sorry, I'm just reading the other question from Ioannis, but yeah, we're actually going to give you a project through which you will be able to apply everything that we'll see together into a real world example. And we're also going to be checking a real world example as well together. Yes, you will receive certificates. Yes, it was actually part of the introductory part, which was last week. And I don't know whether you have to do anything specific to get them. I don't know whether you have to do a specific project or some other kind of challenge. So they haven't really told me that. I'm on a need to know basis. So if there is something that needs to be done, yeah, we will let you know. Okay, great. Yeah, I don't know that, to be honest with you. So yeah, perhaps after the end of the entire course, you will be able to get them. Yeah. So as a reply to Ioannis, the requirements, yes, I don't really understand. Do you want to make this a bit clearer? Like, do you want the TXT file that is required for, installing the libraries? Or I don't really understand what you mean. Could you please reiterate? Okay, great. Anastasia, I don't really know that. I don't really know that. I think you will, however. I mean, I'm sure that there won't be, issues just because of a single lecture. But again, you could always ask Mr. Exarchos, for example. I mean, I'm sure that he will have better knowledge on that. I really don't know.
Can you repeat the question? Sorry.
Yeah, so the question is, if someone happens to miss some lectures due to university, will they be eligible for a certificate? Like, will they be able to get a certificate as well?
Yes, the lectures will be uploaded at the end of the course. However, these should be limited lectures, not, for example, half of the lectures. If it's half of the lectures, the person won't be able to get a certificate. If it's 1 or 2, indicatively, because of unexpected, for example, reasons, of course, it is fine.
Okay, so there you have it.
Yes, because it happens for a lot of days with my university that some hours, let's say, they come in the same hour with these online lectures, and it's kind of hard to actually be in both of those lectures. So that's why I'm asking.
Of course, I understand. Try not to miss many lectures. It is much different if you follow the lectures here rather than in YouTube.
Okay, thank you so much.
Okay, so are there any other questions? I think we actually have to check out the thing that we were talking about with the pass by reference errors, but aside from this, are there any other questions on the materials that we've seen today? Again, I repeat, you will receive the notebook and the PowerPoint presentation with the steps on how to install Python. So you will have these by the end of the day. So aside from this, are there any questions, any comments, any feedback, anything at all? Okay, so yes, of course. So in the next lecture, we're actually going to delve more into data science. We're actually going to have a data set this time. It's going to be a toy example data set. It's going to be Iris. We're actually going to see what that is in the next lecture, of course. But every single one of the things that we're going to be talking about is, can be readily applied to whatever other data set you might have, whether we're talking about biomedical problems, economic problems, what have you. So we're going to start with pre-processing and visualization. This is going to be part of tomorrow's lecture. And we're going to continue later on with supervised learning as well as unsupervised learning in the course of the next days. And in the final day of this seminar, in Friday, that is, we are going to check how we can actually automate all of these with PyCarry. And then there are also 2 lectures, one in the 10th of December and one in the 17th of December, I believe. And we're actually going to check some real data, some real biomedical data to be exact, because this is our area of expertise, and how we can actually handle and work with them. In one of the lectures, we're going to check a classic example of tabular data sets, like how we can actually use classical machine learning and visualization in order to interpret results and get a better grasp of what's going on. And in the final one, we are going to check some more advanced applications in the form of deep learning. We're actually going to see 2 deep learning architectures, one which is created for biomedical images, for COVID-19 more specifically, and the final one would be for denoising electrocardiograms, like removing the noise so that we can make the lives of doctors easier. So I think it's going to be quite interesting. So yeah. There's also another question in the chat. Let me check. Okay, so if that actually didn't work for you, oh, so you mean the workaround that I've actually mentioned in the lecture, I'm guessing. So you will actually have to go through settings of your computer and actually always run PowerShell as an administrator. You are actually going to see that in the notebook that we run through today, we actually do have a solution for that as well. I didn't mention it because I wanted to, go through the rest of the parts that were related more readily with Python, but we also do have a solution for that as well. If this second solution doesn't work for you either, you can always send me an email. Let me also give you my email. And we can either arrange a meeting, or I can actually answer more specifically for that so that we can actually sort the issue out. So it's almost like 8 o'clock around here. I'm guessing it's 7 for some of you. So this pretty much wraps it up for today. I mean, thank you very much for your attention. I don't know if there are any other questions, so if there are, please feel free to ask. I mean, but if there aren't any other questions, because I understand that you would also be tired from the previous lecture, I was happy to see you. We'll talk again tomorrow, and yeah, that's pretty much it. Oh, thank you, Anastasia. Thank you. Okay, so I guess this is it. See you tomorrow. Yes, Attila. Yes, of course. There was a question. Someone raised the hand. Oh, it must have been an accident. Okay. Yeah, George.
Can you hear me?
Yes, of course. Yeah.
I have a question about downloading Python. It's an issue I've come across. So I've done the fix about set execution policy remote signed, the thing you sent, and then when I try to the next step is pip install our requirements, right?
No, the next thing that you got to do is actually create your VNV. Did you do that?
Yes, I've created that.
Okay. Are you inside the VNV or?
Yes, I am.
Okay. And actually, would you like to share your screen now that we've finished? Now that we've finished with the main part of the course?
Yeah, sure.
Let me check if you actually can. I don't think I can. Can you? I mean, do you have the?
I think yes, I think I can.
Okay,
Sorry,
great. Okay, so. Oh, there it is. Okay.
When I try to like do this, a text appears saying could not open requirements file, and no such file or directory. Yeah.
Okay, so do something for me. Do something for me. Write the following command. Write ls. Run it. Okay, so you've actually run the VNV. Okay. The problem with this is that you haven't really created a requirements file. This is pretty much the reason why you have this error message.
Oh, and how do you do that?
Let me show you. Okay, so could you stop sharing so that I can share my screen?
Yeah, of course, of course.
Okay, so, and I'm going to show you something other than this, a bit of a better, practice when it comes to creating such projects. So, give me a second. Okay, so let me share my screen again. All right, so you're probably seeing my screen right now, right?
Yes, I can see it.
Okay, so the first thing that you got to do before, well, this is sort of a best practice that I like to follow. I mean, it's not really necessary, but it will save you a lot of time and a lot of energy when it comes to projects. So what I like to do is actually come here into this PC in Windows, local disk, right? I go through users. You can see the procedure, right?
Yeah, 1 second. Yes. All right.
I go through all of these files, and then I come here, right there in my home screen, and I create a new folder, which is going to be called PRJ. PRJ is projects for short. So I would actually suggest creating this, right? You get in there, you create a second folder, which is going to be whatever you want it to be named. I've named it Erasmus Data Science. Okay. And within this folder, you run into the procedure that we were describing previously. So you create the VNV inside here.
Yes.
Okay. So after you create it, of course, you activate it. You remember this is the command that we had. So it's VNV scripts activate, right?
Yeah.
Okay. So how can we actually go on and create the requirements file? Well, you're actually going through there. You create a new text document, just like that. You name it requirements, which is pretty much the same thing that I have right there. And once you do this, you open it up. You write these three things. These are the main libraries that will also install additional libraries down the line. So you write these three, one underneath each other, as you see right there, right?
Yes.
Once you do this, you save it. So Control S, basically. Another thing that you could do is, basically execute a sanity check just to see that everything exists within your folder. So again, ls. And I can see that within my folder, I have my notebook, for example. I have my requirements, .txt file, whatever. I have an additional folder with data. And once I see this, I basically do the following command. If I write it correctly, it would be wonderful. Yeah, right there. Okay.
Yeah.
Okay, so did it run?
Give me a second because I fell behind a bit.
Okay, yeah, of course, no worries. I mean, we still got time.
So really quick, so I created the PRJ folder you told me about, and I created the second folder in there called Python, for example.
Okay. Python is going to be a bit of a problematic name because
Right.
Python files actually are within a Python folder. So I would actually suggest to name it something different, like, I don't know, name it Erasmus Project Data Science, whatever. I mean, something that would be a bit more neutral, language neutral, so to speak. This is what I would advise.
All right. I renamed it. And how do I put the VNV in there? Because I go ahead and do the steps, but it doesn't put the VNV in there. The folder is still empty.
Yes, the reason behind this is because you will have to create a new VNV in there. Like the first thing that you got to do once you're in this folder. So let me show you. So, okay, so let me show you. So let me deactivate this, running into spoilers. So we are in kind of a similar situation, right?
Yeah.
No, let me recreate it. So I create my new folder. And I'm going to name this test, for example, right? Which is pretty much identical to what you're doing right now.
Yes.
I'm getting in there and I see that everything is blank. There is nothing in there, right?
Exactly.
Okay, so I go on with the right click of my mouse and I do this. I open in terminal.
All right.
Once you do this, you're going to see that your path, or rather the location that you are situated right now within your file system, is within PRJ and more specifically within test, right?
All right. Yes.
So when you do this, you do this. If you do this, a VNV is created.
Yeah, I can see.
Okay. Is the folder being created?
1 second, because I think I did something wrong. Let me try again.
Okay.
And for some reason, it tells me that access is denied.
Oh, so you have to do the other thing that we've talked about. So the other thing that you got to do before you run this, okay?
Yeah.
The other thing that you have to do, I'm going to give you the link once again. I actually had it in chat, so let me copy it. You have to follow the link right there.
And I copy set execution policy again, right?
Yes, exactly. So if you haven't done this, what you need to do is open PowerShell as an administrator, that is. So you basically go through your search. You search for PowerShell, Windows PowerShell, right? And what you do is that you right click on it and then run as administrator.
Yeah.
And once you do this, you get the set execution policy command. You copy it and you paste it, and then you basically run it. And that should do the trick when it comes to, running with that kind of thing. When you actually want to.
I also pressed Y and then
Okay.
press Exit.
Yes.
To close
Yes.
it. Exit.
Mm-hmm.
Okay.
Okay, so try doing it again. Go to your other terminal now and
all right.
Do the same kind of command, like Python, /m vnv vnv.
All right. Same thing again. Access denied.
Really? Okay, so probably the way that you would fix it is through the second workaround that I also mentioned before. So another thing that you would probably have to do is run through your PowerShell as an administrator every time. So in order to do this, you basically have to go through settings, and basically there is an option right there which says run as administrator every time. You're actually going to see this. I actually have it in the notebook that I'm going to provide you with. So I'd suggest that you try this as well. We're actually going to give you the notebook today. And if that doesn't work out either, we can, come back to it and basically sort it out. So is that okay with you?
Yeah, of course. Thank you very much.
Okay, you're welcome. Okay, so another one when I do this step, okay, Python not found. Okay, so does Spider actually install Python on your computer? I don't know this. Or does it install a Python that is readily available within the environment itself? Because there are certain tools that actually use Python through specific environments, like through Spider, for example. And I think the same pretty much applies with some instances of Jupyter or UV. There is also another system which is similar to Jupyter and Spider, which is called UV, through which you can actually use Python to create projects, but Python is not really installed into your computer. So I would suggest that I would suggest to basically use Spider as your editor, like, to edit your code and experiment with it. Yeah, I think that this is the best way to go through with this, like for, the course at least. Okay, so, sure. Okay, so are there any other questions or, comments or anything? Okay, so this pretty much officially wraps it up for today. So again, thank you very much for your attention. Thank you very much for being here, even though it's well past 10 minutes of the lecture time. So I'll see you all tomorrow. So have a good one.
Good night. Bye.
Good night to you
Thank
too.
you. Good night.
Bye.